Plutonium. Even the name sounds ominous. It's the element that powered the bomb dropped on Nagasaki. The fuel quietly burning inside deep space probes sailing beyond our solar system, and one of the most tightly controlled substances on the planet. But what exactly is it? And how does something this extraordinary even get made? Welcome to Brain Popcorn, where science, history, and discovery collide. Today, we dive into the extraordinary and unsettling history of plutonium. Plutonium is a silvery gray radioactive metal with the symbol Pu and atomic number 94. It emits alpha particles, neutrons, beta particles, and gamma rays, and every one of its 5 common isotopes is radioactive. Here's something that surprises most people. Plutonium is almost entirely a human invention. Trace amounts exist naturally in certain uranium ores, but beyond those nearly undetectable quantities, we made this element ourselves. The credit goes to chemist Glenn T. Seaborg and his team at the University of California, Berkeley. Between late 1940 and early 1941, they bombarded uranium with deuterons in a 60-inch cyclotron and produced a brand new element. They named it plutonium, after the planet Pluto, continuing the pattern set by uranium and neptunium. The symbol Pu was Seaborg's quiet joke, a nod to the childhood expression for something that smells bad. The naming committee accepted it without a word. Soon after its discovery, the team confirmed that plutonium-239 was fissionable with slow neutrons, capable of fueling a nuclear bomb. That finding launched plutonium straight into the Manhattan Project. By 1942, Enrico Fermi's team had achieved the first self-sustaining nuclear chain reaction in Chicago. Reactors were built at Oak Ridge and then at the massive Hanford facility in Washington state. By spring of 1945, they were producing plutonium by the kilogram, less than 5 years after the element had never been heard of. So, how is it made? When uranium-238 inside a nuclear reactor absorbs a neutron, it becomes uranium-239. That unstable atom sheds an electron and becomes neptunium-239, which then transforms again into plutonium-239. This chain of atomic transformations happens continuously in every operating reactor on Earth. Spent nuclear fuel from a typical reactor contains about 1% plutonium by weight, and there are metric tons of it stored around the world right now. There are 2 kinds worth knowing: reactor-grade and weapons-grade. Fuel left in a reactor for roughly 3 years produces reactor-grade plutonium. Fuel pulled out after just 2 to 3 months produces the purer, weapons-grade variety. Once produced, extracting it requires a chemical process called reprocessing, most commonly using the Purex method, which separates plutonium from uranium and other radioactive byproducts. The recovered plutonium can then be blended with uranium to create MOX fuel and fed back into reactors as a power source. Is plutonium really the deadliest metal on Earth? Externally, it's less dangerous than its reputation suggests. Alpha particles are stopped by a sheet of paper. The real danger is internal. Inhaled plutonium dust lodges in lung tissue and kills cells from the inside, leading to scarring, lung disease, and cancer. It can enter the bloodstream and concentrate in the bones, liver, and spleen for years. Studies of workers at Russia's Mayak nuclear facility confirmed elevated rates of lung, bone, and liver cancer directly tied to plutonium exposure. What makes it truly formidable is its nuclear behavior. When plutonium-239 absorbs a neutron, it splits and releases more neutrons, which split more atoms in an exponentially accelerating chain reaction. Just 10 kilograms in the right configuration can produce a weapon capable of leveling a city. And yet, plutonium has a quieter side. Plutonium-238 generates steady heat through radioactive decay, making it a remarkable power source where solar panels are useless. The Voyager probes, launched in 1977, and still transmitting from the edge of our solar system nearly 5 decades later, run on plutonium-238. So does the Curiosity rover on Mars. One of the most dangerous materials ever created is also what carries our eyes to the farthest corners of the universe. Born from curiosity, forged by war, and quietly powering our reach into the unknown. It's hard to think of another element whose story spans quite so much of what we are.